So this is one of our technique videos. What we're going to be doing today is doing a plate count of all the various organisms that's found in our product. And I'll remind you that when we did the video tape of sauerkraut and we salted it down, we drew out the water, and then we took some of the liquid part and we did some enumerations. And that was T0, and I don't know if we can pick this up, but this is 2 days later. So what you see here has microbes, but there's so few that you don't see the turbidity. Here you have a thick, turbid micro mass there. So what we do to enumerate microorganisms in high numbers, we do something called a serial dilution, which I made a serial dilution -1, -2, -3, -4 by taking a pipette of this, shaking it up, move it over here, and I know what each one of these dilutions are. Now this dilution range, we always set up a three concentration range to get a total plate count, because we don't know where it's going to hit. So we'll run 3 consecutive serial dilutions, and we're going to use a 4-plate method. We're going to take an aliquot out of this, plate on the media, and then we're going to write the name of the media and the final dilution on this Petri plate. So now we have a serial dilution already made, and I have 1, 2, 3, 4, 5, 6, 7 types of enrichment media that we use for enumeration of organisms. We have the EMB for the gram negatives. You saw that from a previous video. I have potato dextrose to enumerate yeast and molds. We'll talk about yeast and molds later. I have plate count agar that enumerates everything. So we're going to have a total count on that. And then I have 1, 2, 3, 4 types of enrichment media for the various lactobacilli that we expect to isolate. And they have different names. We have sucrose. We have something called MRS. We have something called milk. It's got milk and so forth in it. And we have, look at this one, tomato juice agar. So each one of them are specialized in different types. So in order to do this plate count now, we're going to do, we have the dilutions already written down that we want to use. So what I'm going to do is I'm going to consolidate all the dilutions at one time. So I'm going to take the -6s, so 6, yeah, and they come from this dilution. I'm going to take the -5s, 5. Let's see, I want to put them up that way. We're going to plate this dilution. And then the -4s comes from this dilution. Now, we only have 2 from the EMB. Now, what we expect to happen in the 2 days of growth under the salt conditions, we expect to wipe out a lot of the gram negatives. So I only have a -1 and a -3. So a
-2 and a -3.
A -2, -3. So look, what I've got now, I've got my dilutions, and I'm going to plate these out, and I'm going to use the pour plate technique, and we're going to spread them, and you're going to watch me do it. Now, okay, so one thing before I start pipetting this, a lot of this, to keep from making mistakes, you prepare all your dilutions, label all your labels before you even start, so you don't have to really think about what you're doing. So what I'm going to do now, I'm going to pipe plate the -6s. I'm going to need some. So we're going to turn this over, and what we're going to do? We got sterile pipettes, and we can put our finger on this end. This end is sterile, and I can turn it around so I can see the scale down here, and we're gonna, holy smolies, these glasses. Can you see the meniscus? Maybe. All right. I'm going to go from the top to the bottom. I'm putting 1/10 ml of that dilution. Neat. So now I've plated this dilution. I'm through with this. I have a homemade spreader here. Looks like a hockey stick. And this is 95% ethanol, and look what happens. You don't want this out. I'm gonna pass it through there and sterilize that burn. All right, now watch this. You take the lid and you use your fingers and watch how I'm doing this back. I'm spreading that 1/10 ml all the way across the surface, and I'm spinning that plate. And I know I got it flat because you don't see anything under this. So I'm spreading that thing, and how long to spread it? That long. When you're making pour plates, you make the media up a day or two ahead of time so that it can dry out. So you want a very dry surface when you're plating these things. So all I'm doing is spreading that 1/10 ml over that media. Now we're going to turn.
Explain to them that you don't have to reflame between each plate.
All right. The reason I'm not reflaming is that these are all the same dilution. And assuming, and I got glasses on, you don't have any contamination on the plate, you can spread all 6 plates without reflaming. All right, so that concludes the enumeration part of both the for the sauerkraut and for the pickles. And one of the things that I've noticed that on the plate counts we did on the sauerkraut, and then the following day we did the same on the pickles, that of all the media that we did, in every case, for example, I don't know how close I need to be, that one of them is from pickles, T0, the other one is from sauerkraut. Their counts are almost identical. So what that means is when you're fermenting a vegetable and they come from the soil, you're going to have the same general population. And so every fermentation we do in different stresses, so we can see how they get eliminated. So it doesn't matter where you're at, you got the same counts to start with. Now, I want to say that of the lab part of all of these fermentations is going to be sort of like that. We're going to do the micro over time. we're going to do T1 day, T0, T2, T5, 7, T14, T28, and so on. So we're doing this for the duration of the fermentation. So we can plot this, put it on online, and you can see how it happens. The other two things that we do each time is we do pH, which we're going to turn it on. Now, oops, I got a vessel. And what we're going to do on a pH meter, it takes a little bit to stabilize. We keep a buffer in this over the probe. This is a combination pH probe, measures in millivolts, converts it to a number. These probes have a little hole in it so that the hydrogen measure the hydrogen ion concentration. I always like to rinse that off. So what we're going to measure first is a buffer to make sure that the machine is, so we pour a little pH 7 buffer and we read it. If it's close enough to 7, we won't calibrate. If it's not, it is reading 7.0. So it's right on the money. We don't need to buffer the machine. So what I'm going to do is take 10 mLs of this solution and put it in a beaker. All right, 10 mLs of the T2 sauerkraut. All right, so I took 10 mLs of that. Now, when you're doing a pH, we're measuring the hydrogen ion, so I can put as much distilled water I want in here. It's not going to change the activity. So I'm going to add some distilled water so that it's deep enough to get the probe in, and then we just stick the probe in and let the machine tell us when it's adjusted. Kraut pH. Okay, so this is the last chemical test we're going to do on the sauerkraut. Some of you have had chemistry already. You know what a burette is, and it's a titration device, and it's got numbers and scales. So what we're going to be doing to do total lactic acid, we're going to use a 10th normal sodium hydroxide. We're going to use an indicator called phenolphthalein, which is colorless until you get to the titration endpoint, and then it turns pink or red. So that tells us what, and the volume that we use, we got a formula that I'm going to explain to you, and I'm just going to say it out loud because you're going to see it again. So to calculate how much lactic acid is, in the numerator, we're going to multiply the volume used to get to the pink times the normality of the sodium hydroxide.
The volume of what?
The volume of sample we put in there. Now, it's in the denominator. But in the top, we're going to measure how much milliliters times the normality times the equivalency of lactic acid is 9. So we're going to do that and tell you what that is, and then we're going to divide it by how much sample we put in there, which is 20. And then we're going to come up with percent lactic acid. Simple. The faster I do it, the faster it gets.
Oh my God.
God damn it.
Don't drop anything.
All right, let's get these drops going here. Normality NaOH times 9